Start the first chapter of chemistry, class 9th. In the first, we will discuss the matter and its property. Clear? First of all, we will discuss what is matter. We have a wide variety of examples of matter, such as we will take pen, pencil, bricks, air, plants, animal, chalk, board, bus, etc. What is the similarity in this kinds of example? What is the similarity is that the first one is that all pen has mass, yes or no? Pencil has mass, bus has, bricks has mass, air has mass, plant has mass. It means they have, what they have? They have mass, the first one. And the next one is that they occupy space. It means anything which has mass and occupies space is termed as matter. What we got? The definition: anything which has mass and occupies space. It has anything which has mass and occupies space, what we call it as having volume. Then it is termed as matter. Clear? Pen has mass, it occupies space. Pencil has mass, it occupies space. Bricks has mass, it occupies space. Air has mass, it occupies space. It means anything which has mass and occupies space is termed as matter. Clear? Let us know whether the air is matter or not. What is the question? Question is that air is matter or not. We will check whether the air has mass or it occupies space. In order to check it, we will take a balance. Which is, and then take two balloons. Take two balloons. Place one balloon here and another balloon here, and then balance it. Clear? After balancing it, we will take the next balloon and then fill it with air and then place it. What we see that this pane moves downward. Why this is so? Because on filling air into balloon, the mass of this balloon containing air increases. That's why it moves downward. By doing this activity, we know that air has mass. So the next one, we know in our cylinder, LPG cylinder from our daily life, we know it contains 14 kilogram of gas and 15 kilogram the weight of the cylinder. We know when the cylinder is evacuated or when the gas is used, it is light in weight. Why it is light in weight? Because of absence of air into it. But when gas was filled in it, then it has more weight. In this way, by this observation, we know that the air has mass. We know to the next one, it occupies space. How we will know? Let us do understand by one activity. We will take a bucket and then fill it with water. After filling it with water, we will take a tumbler, a glass, empty tumbler, and then invert it. By inverting it, we will place it inside the water. By placing it, what we observe that it is quite difficult to press it inside the water. Why it is so? Because water does not get it inside the glass. But as we tilt it, when we place it in water and we tilt it, what we see that the air bubbles are coming out. Why it is so? Because previously when we are pushing the glass inside the water does not enter inside the glass because the space in the glass is previously occupied by air. But as we tilt it, the air escapes out in the form of bubbles and the water enters in. It means the air has tendency, by this observation we can say the air has tendency to occupy space. To the next, we know that matter, it has mass and occupies space. Then you have a question in your mind that what is non-matter? Let us discuss what is non-matter. What is non-matter? Let us take an example. Let us discuss what is non-matter. We know what is matter. Matter has mass and occupies space. The next, what is non-matter? You know the ideas. If ideas, thoughts, if they are going to occupy the space, and if a little idea occupies such much space, we know a variety of ideas is in our mind. If it is going to occupy such much space, then in that condition, our mind will blast up. But this is not happen. Why it is not happening? Because the idea, dreams, they have not able to occupy this space. That's why they are the example of non-matter. One more example I have, which you observe in your daily life, that the sunlight energy is non-matter. Because energy has neither mass. Can you beat sunlight? No, because it hasn't mass. It does not occupy space. It means the energy is a good example of non-matter. Energy, that is sunlight. The next one, heat energy, etc. These are the example of non-matter. Clear? Non-matter, it means it has either not mass nor it occupies space, then it is termed as non-matter. According to ancient Indian philosopher, what we know? According to ancient Indian philosopher, the matter is composed of 5 basic elements. You know, the matter is composed of 5 basic elements. You know, you have heard that Chitijal Pavak Gagan Samira. Chiti means the earth, Jal means water, Pavak means the fire, Gagan means the sky, Samir it means the air. It means according to ancient Indian philosopher, the matter is composed of 5 basic elements. That is Chitijal Pavak Gagan Samira Panch Tattva se bane sharira. It means the matter is composed of 5 basic elements. The first one is earth. The next one is water. The third one is one is sky, and the fifth one is air. Clear? Chiti, Jal, Pavak, Gagan, Samir, according to ancient Indian philosophy. But we classify the matter based on their physical and chemical property. Clear? Based on the physical and chemical property, matter is categorized. Let us see how it is categorized. Matter. First one, based on physical property. We know physical property. We know what is physical property. It means the property which we observe during a physical change. But the question arises in our mind that what is physical change? Physical change means what? If we have ice and when we heat it, it is converted into liquid water. What we see here, only the state is changed, but the composition remains same. No new substance is being formed. The composition in the state ice is H2O, and the composition liquid water has H2O. It means no new substance is formed, but the change has occurred. It changes from solid state to liquid state. If this happens, this change is termed as physical change. What we observe here during this change, we got a property, that is the temperature at which a solid changes to liquid. That property is termed as melting point. It means the melting point is the physical property. Based on the physical property, what are their state? They are categorized into three types. The one is known as solid, the next one is known as liquid, and the next is known as solid, liquid, and gas. You know, solid, the molecules are compactly packed, and if the molecules are compactly packed, there is strong force of attraction in between them. If there is strong force of attraction between them, they have fixed shape, fixed mass, and fixed volume. They will not flow. Why they will not flow? Because they have strong force of attraction between them. If they have stronger forces, they have least intermolecular spaces, and if they have least intermolecular spaces, they are incompressible. The liquid, we will discuss, they have lesser force in comparison to solids. Their molecules have lesser force, so for that they have random motion. If they have random motion, they have greater kinetic energy, they have more interparticular space, these are also incompressible. To the next, we will discuss gases, they have least force of attraction. If least force of attraction is there, the molecules are free to move randomly. They have most kinetic energy in all the three states. They have tendency to flow. They will fill the container. They have not fixed shape, not fixed volume. In case of liquid, they have fixed volume but not fixed shape. That means when we pour a liter of liquid from a cylindrical flask to another conical flask, then the shape will change but the volume will remain same. It means the liquid acquires the shape of the container in which it is kept. We will discuss all this state, solid, liquid, and gases in this chapter. But before that, let us know what is the classification. The next, based on the physical property, it is categorized into solid, liquid, and gases. But to the next one, based on chemical property. Based on chemical property, it is categorized into pure. In the next one, it is categorized into impure. Pure, it is categorized into element. The next one is compound. and impure it is categorized into mixture. Mixture it is categorized into two types, homogeneous, and the next one is heterogeneous. Clear? Let us see. Based on the chemical property, it is categorized into pure and impure substances. Pure, that is element and compound, and impure, it is mixture, and it is of two types, homogeneous mixture, and the next one is heterogeneous mixture. Next to that, we will discuss it. In this chapter, we will discuss solid, liquid, and gas state. In the next chapter, we will discuss compound and element. And next to that, we know element is categorized into three types: metal, non-metal, and the next one is metal. Compound is categorized into three types: acid, base. Clear? So the next we will discuss. Let us know that the matter is made up of particle. In order to know it, we have to perform activity. What we know? We want to know matter is made up of particles. How we will know it that the matter is made up of particles? We will perform two activities. The first one, what we do, in order to define it, we will take a piece of, a part of K, we take a part of KMNO4. You know what is the color? Its color is purple. We will take beaker having some water into it. Then place a part of KMNO4 into it. When we have a small particle, but when we dissolve it inside the water, what we see that the whole water turns purple. But it's so because it turns into purple because this piece is composed of various small particles. When it is dissolved into water, it is broken down into its constituent particles and is spread throughout the solution. When it is spread throughout the solution, that's why the whole solution turns purple. Next today, we will take another beaker and we'll take some water into it. So the next we'll take 1 teaspoon of this solution and pour into this. Again what we see that the solution will turn purple. Why it is so? The solution we have taken, it consists of the first one, what we have taken, this one is small particle. When we dissolve it, it is broken down into various small particles. To the next, when we take few particles and when dissolving it into the next water, which we have taken in the next beaker, then it is also broken down again into smaller and smaller particle and distribute throughout the solution. That's why the solution turns purple, but the color is light. To the next, we will take another beaker, fill it with water, and place few drop of this solution into the next beaker. What we see? We see that this solution also turns purple. From this activity, what we observe from this activity what we observe that what we observe activity, we observe that in the first case we have a particle of potassium permanganate which is small itself, but when we dissolve it, it is broken down into constituent smaller and smaller particles. Why it is so? Because this piece is also made up of a smaller particle. When we take one piece of this MnO4 and pour into it, it is further broken down into a smaller particle. When we take few drops of this, it is further broken down into a smaller particle. It means, why it is so? It is so because this MnO4 crystal which we have taken, it is made up of a smaller and a smaller particle. Clear? How it is happening? Let us see with another example. Suppose this is potassium permanganate. When we take this one drop from here and place into another, it is further broken down into care for the size too. When we take into another beaker, it is further broken down into. In this way, we can see that the particles of the metal are very, very small. Potassium permanganate, the crystal is metal, and this crystal, this particle is made up of very and very small particle. By this activity, we can say that the matter is made up of very small particle. Let us know it by another activity. For example, we will take a cylindrical jar. It contains air. We will take another cylindrical jar. And fill it with bromine gas. We know what is the color of bromine? That is brown. When we join this two cylindrical container, what we see, the whole, when we join it, what we see, that the whole container turns, that is brown. Why it is so? Because the particles of these gases are very, very small, that is brown. When we join them, they intermix. It means these gases accommodate the interparticle space of these gases. Why it is so? Because these gases are very, very small, therefore they intermix